Hello everyone and welcome to SNS Study Station. So here today we are going to see about the degeneracy in transportation problem. This is a topic of transportation problem in the subject operations research, and here today we are going to see something called as degeneracy. So what is that? So as you can see the question here it is mentioned, obtain the initial basic feasible solution using least cost method and then optimize the solution using UV method. This is what we need to do, and then there is a transportation cost table which is given here. So what needs to be done? First thing is initial basic feasible solution we'll find out, and then UV method we'll use for optimization. So here phase first we'll go for initial basic solution. So initial solution we have to find out by using the LCM method. So LCM method, least cost method, means where and all least cost is there, that we will take and find out the initial solution. Okay. So this transportation table we will take, in this we will find out we will take the allocations, and this is how we will get the least cost. So here least cost method says first we have to select the least cost. So this phase first we'll do quickly. So which one is the least cost? Which one can you see as the least cost here? So I think 2 is the least cost, right? So first we will go with 2. Here we have this 2 and this 2. So any one 2 we can take and allocate. So here I will make this table, and this is how we can do the. So here this table I have made. LCM says, least cost method says, first we have to take the least cost and do the allocation there. So least cost is 2, this 2 and this 2. We have both the places we have the least cost, so any one we can select. So we'll do the allocation here first. So here you have to see the demand and supply. Demand is 20, see, and supply is 35. So here least one we can allocate, 20 we can allocate here. So with this will become 0 and this will be left with 15 because 20 we have allocated. So this 0, that means this whole column will get cancelled. Okay. After that what we need to do is then again find the next least cost. So again we have the other 2. So now here we will allocate demand and supply. Demand 10 and supply 40. So 10 we will allocate. This will become 0 and this will be left with 30. This 0, that means whole will get cancelled. Now next is this 3, next least cost. So here we will allocate 15 as supply is 15 and this is 40. So we will be left with 25. So with this 0, this row will get cancelled. Now what all we have in that, 4 is the least cost. So 4, here we will allocate 30, 0, and this one will become 5. Then this also will get cancelled. Now we are left with 4 values, 15, 20, 15, 8. Okay, 6 values, 14, 13 is also there. So we will take 8. 8 is the least among all these. So now 5 we will take, this 0, this 25, and with this 0, this will get cancelled. Now we are left with 4 values, out of which least is 13. Rest all are already cancelled. So here we need to take 25. 25, and with this 25, this also 0 and this side also 0. So this cancelled and this also cancelled. Now we are left with this 15 only, and here we have to allocate 20. Demand also 20, supply also 20. So that you already know, first you need to check demand and supply whether these two are equal or not. Then only it will be a balanced problem, otherwise that will be an unbalanced. So we have to make it balanced and then solve the initial solution. So here we have solved it. Now total cost For total cost, you need to see the allocations and then write the value. You need to see the allocations, where and all allocations are there, like this B column. If you see 20 into 2, 15 into 3, 20 into 15, 10 into 2, 30 into 4, 25 into 13, 5 into 8, like this. So all allocations you need to multiply with the cost, and then you will get the total cost as rupees 890. So here we have calculated, like phase first we have done. We are done with the phase first, and initial solution we have found out. Total cost we got as rupees 890. Now we have to go for the second phase, that is optimization. So this same we will take, this same table we will take, all the allocations we will take. So this I have taken here. Now here phase second, optimization by using UV method, that we have to do. So here first step is we have to check for m plus n minus 1 equals to allocated cells. That should be there. This we need to check. So m is number of columns, n is number of rows. So m, how many columns? A, B, C, D, E, 5 columns, plus number of rows. Rows are 4, minus 1. 5 plus 4 minus 1 equals to 8. And how many allocated cells are there? So if you check 1, 2, 3, 4, 5, 6, 7. Allocated cells are 7. So this is not equal, because m plus n minus 1 is 8 and allocated cells are 7. So this is not equal. That is what it is known as degeneracy. Now what we need to do is, here among the unallocated cells we have to take the least value among the unallocated cells. So what all unallocated cells are there? Least value is 5. So 5 is here also, here also. So we can select any 5. So randomly I am taking this 5. Okay. So now from here we should check. Closed loop should not be possible. Closed loop or closed path we used to make, no? So that should not be possible. Okay. Only open loop should be possible from here. There means, loop means if we are starting from any cell, so wherever we go, but we should come towards that cell back. We should come towards that cell back. So from our origin we will move, and then we have to come back there again. Like this we need to do this. So this is a closed loop. Now we need to check the closed loop should not be possible. Okay, from this 5, closed loop should not be possible. So from here what we can do is, from here we will check whether any closed loop is possible or not, and we can move towards allocated cells only. So from here we can go up as well as we can go left. So but if we'll move towards the left side, so then we cannot move anywhere. So we'll move up. So we'll come to this cell. Then next allocated cell is this side. We'll come here. Then next allocated cell is down here. Then next is this side. Then up. Then this side. Then we cannot move. So here we know this closed loop is not possible. Only open we can. Like we cannot come back to our origin. So this is what we need. So that means here from 5 we have started. So here we can give it as epsilon. E we can give here. This is what we can do. Okay. So this can be done. So with this, now what we need to do is, now same UV method. With the help of UV method, that means this only says, now we have to find out the U and V values, and then Pij values we have to find out. So Pij values is Ui plus Vj minus Cij. Like this we can find out all the Pij values. So here now if you check, m plus n minus 1 should be equal to allocated cells. So m plus n minus 1 is 8, and allocated cells now is 1, 2, 3, 4, 5, 6, 7, 8. because this cell 3 2 also we have given as epsilon. Like we don't know the value here, but we have given it as E. So that is what we got. So now the next step is we need to find out the U values and V values. So column values, we have to find out U and V values. So this row values are U and column values will be V values. So column we have 5. So like this we have to find out the values, and this you already know how to find out these values. Okay, U1 always we take as 0, and then based on the by taking the allocated cells, with the help of allocated cells only, we can find U and V values. So here okay, we will find out the U and V values. Like first one I'll tell you. So U1 is 0. So in this U row, in this first row, U1 row, you can see the allocated cell, this one. So with this we can find the V2. V2 is there, no? So U1 is 0. U plus V should be equal to this. So U is 0. So what should be V? So that we can get 2. V should be 2. So 0 plus 2 will be 2. Like this we can find out all the values. So from here, U and V values I have calculated by using the allocated cells. Now we have to find out this Pij. So this Pij values we need to find out here. So for this formula is Ui plus Vj minus Cij by using the unallocated cells. So this I have calculated here. So like this you can see all Pij values I have calculated. So here we have to check all Pij should be less than equal to 0. But here we can see two positive values, 13 and this 2. So out of which we have to take the maximum positive value, that is 13. That is coming in cell 2-1. From here we have to make a closed path. So this is what we need to do now. So here we will make a closed path starting from cell 2-1. Cell 2-1 is here. So from here we have to make a closed path now. Okay. So from here we will move, obviously we don't have any option. We can move downwards only. Then from here we can move this cell. From here upwards. Then from here we can move towards this cell. This is also allocated cell. Then from here down. Then this. Then this. Then this. And we have come back towards origin. And then alternatively we have to give the plus and minus symbols. So we'll start from here minus, plus, then minus, plus, minus, plus, minus, plus, minus. Okay. And this, by using this plus and minus symbols, we have to make a new iteration, a new table. And then out of the, where and all minus symbols are there, you can check the least allocation. So least allocation we have to take. So here we can see the least allocation as 20. So this we have to add and subtract at the respective signs places. That we will do, and we will make a new iteration. And then again we will repeat this step, n plus m minus 1. From here we will repeat everything. So let's do that. So here again we have to check this, like we have got this new iteration. Again we have to check this m plus n minus 1 equals to allocated cell. So here again we are not getting it equal, because here we have 7 allocated cells only, but it should be 8. So again we will take the least, among the unallocated cells we'll take the least value, and then see whether there is possibility of closed loop. If there is closed loop is possible, we cannot go forward. Only open loop should be possible. From 2 I have started. From here I have started and checked, only open loop is possible. So that means here we can give it as E. And then again same U and V values we will find out now, because now we have 8 allocated cells. Now here I have taken all U values, V values, and then this Pij values I have calculated. So here you can see all Pij values are negative. All are negative. That means we have got our optimal solution. Now we just need to take the allocations and multiply the allocations with the least cost here. So here we will take the allocations and multiply. Where E epsilon is there, so here no need to worry. about